Now the wall in the front that has the windows punched out of it will otherwise look like this wall. So I'm going to copy and paste this, and this is going to be where you need to make geometry to punch out of here to make our windows, and then later actually become our windows. So this part is fairly arbitrary. Right click and hold on the sides and say delete the channels. And then of course shift click on this. I want to make a window that maybe is 1 unit by 2 units by 1.5 units. I made it purposely thicker than it needs to be, just to ensure that when I subtract it out, it wasn't like coplanar or something with the wall. In any case, it can't be too big here. So there we go. That's what I came up with, or maybe a little bit thinner to make it more of a windowy look. And from here, I want to have 2 windows. So I'm going to say, let's actually transform it to along the z-axis. Let's translate it 1.5 in one direction. And I'm going to say, I can do this again, where you say create reference copy. Really lazy way of just getting this one. And a negative in that direction. If you want it to be a little cleaner, we could just copy and paste this and say, let's just take that and then paste relative references here and negate it. The point is that we started here and we had one go in one direction and one go in the equal and opposite direction. Merge those together, and these will be later the basis of our windows, but for now, the basis for the things that we punch out of this wall. And to punch out, we'll use a Boolean. The Boolean is a cool thing that comes up a lot in fracturing, which basically says take one shape and either subtract out the other shape or intersect it or union it and make it one new big thing. We want to do the default, which is subtract. And we end up with this. Real quick though, as an aside, if you're wondering why there's this extra line here and here, it's because you can't have a hole in a polygon. You're going to have, I mean, it won't look like there's these lines when I go to smooth shaded, so it will look like there's some holes here. But in reality, there's this. So what it's saying is, imagine point per point, this polygon, let's say, starts here and goes 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we end up ending where we began. So we traced out a polygon that had no actual hole in it. This was the edge of the polygon the whole time, just oddly convoluted. Just so you know, that's why those are there, and don't worry about them because they won't be seen. In any case, we successfully made our front wall. So let's grab all this stuff again, copy and paste. This is going to be called wall front, as I said. And this one's going to be a little trickier though, because we only want this to show up in the front. Currently, it's in the back and then it's duplicated. So we already know we don't need it to duplicate it in X at all. So I'm just going to go ahead and delete that. So it's still in the back though. I mean, I'm showing you in wireframe because it's on top of the solid wall in the back. But we need to move it forward 2 times, but not actually duplicate it forward. So I'm going to say, let us take our thing here, and let's move it forward in the X amount, the X size amount, like so. And let's say that became the answer. Well, it moved it forward 1 time. Okay, well, it's not really enough. So we need to move it forward 2 times. And now it's enough. Thing is, in keeping with our whole procedural nature of all this, we should probably do it in terms of how many times this was doing it when we were actually copying it forward on the regular wall. So let's take this total number here and have that, instead of us hard coding this too, let's I'll just put it on this side. Let's paste relative references here. So it's still 2, but now if I ever, if we ever change this, if we change these here, it'll keep pushing the wall, the ones with the windows, to the front. Cool. Put it back to 2 though. So that's nice. And now to put actually make our windows. Now the windows we kind of got started with already. This was our window. So I'm going to move this over here for a minute, and I'm going to say, let's just take this thing that we started with already, and let's make it be thinner. I'm going to say, scale it in the X dimension. We can hide this again. Scale in the X dimension 0.05. Now this is weird. It moved it in addition to making it thinner. And that's because it was scaling it relative to the origin here. So as you can see, it's taking the whole space and shrinking it towards here. So that doesn't quite work. We need to change where it's scaling it relative to. So we need to move the pivot. Again, this manipulator thing that you see here, we don't want it to be at 0, 0, 0. We want it to be in the center of this thing. So what we can just say here, there's a few ways we could do it, but I'm just going to say, we already know what the center is. It's right here. So copy that parameter and do a relative references. So now, when it scales it, it's scaling it from its own center. Very cool. So this is our window. I'm gonna grab this pack and kind of definition thing here, move it over here. This is going to be called not concrete anything. This is a glass window. So like so. We wanted to still move it in the same way as we had moved the holes before. I'll move this up a little bit. So I'm going to take both of these nodes and the merge, and I'm going to say create reference copy, like so. And I'm going to move these 2 inputs to here. So now we have 2 windows. These windows are packed, so really we already have 2 instances now of our one window definition here. We can go ahead and put our own color node here. And I'm going to say make it blue because, it's like water. Water is not usually really blue, and glass isn't really blue, but it kind of feels blue because it's usually reflecting the sky. And we might as well have it move in the same way that we had this here. So I'm going to merge it like so, and now they'll all kind of move as one through the rest of this process. However, we don't want this color node to overwrite the blue that we just made. So instead I'm going to move it up to be here right after the wall front. So cool, we're almost done. I'm going to take an opportunity to say, let's have none of these colors really reference each other. So I'm going to delete the channels and all the colors. I selected them all, went to right click and said delete channel. So the first 2 things, the floors and the columns, let's have those be dark. We'll make real materials later on. But for now, this will help us to kind of visualize what we're working towards. I'm going to have all the wall stuff, both the small walls, the big walls, and the front walls. Let's have them be like a lighter gray, something like that. Yeah, whatever. That's good. We already did the color on the glass, so that's done. And the absolute last thing that I think we need to do for this chapter, and then we can get to fracturing finally, is, this looks a little ugly, doesn't it? The floors don't really, there's like a weird gap, obviously. So what I want to do here is say, let's scale them up. Let's make them wider and longer. So back here, when we had our entire floor, and I'm gonna turn the template on here and then just turn it off because I just don't want anything templated anymore. Let's make this bigger. Let's just scale it up. Now, as we saw before though, when I scale things here, they're going to scale around this, around the origin. I don't want that. I want to scale around the center. So what we can do, instead of referencing some other parameter that had the right value for us, we can just say, well, we can see if I middle click and hold, we know what the center is. It's apparently 204. If I were to put 204 here, you can see that's correct. It moved it to the middle, which is what we want. But to do it more procedurally, let's use a little expression called centroid. Centroid will get us the center. So a lot of expressions that we'll see today and in general take a first argument that's often going to be 0. 0 means do this in terms of the incoming geometry, meaning input 0, which is often the only input a node has. So 0 just basically means do this in terms of the previous node, which is what you always want. You can't do it in terms of the node itself because the node itself hasn't figured out the result of itself yet. So you always have to do everything in terms of the incoming node. So what do we want here? We want the x component. So we put dx. As you can see here in the tooltip text, it's dx, dy, and dz. So for the x, obviously, it's dx. For the y, it's y. For the z, it's z. So now we have still 204, but now it actually just figured it out for us. So as we change stuff around later, it'll still work. So let's look at the end again and go to the transform. And I'm going to say in the x direction, let's make it 10% bigger. So anything times 1 is itself. So it has to be 1.1 to be 10% larger. Actually, let's do 1.1 in the x direction. And let's do 1.05 in the z. Because it's twice as long in the z, so we need less scaling for it to have the same amount. And there you go. So we have our procedural building. And we'll swap out, we're going to fracture one example of each of these things, one column, one small wall, one big wall, one glass, and then we'll replace them all with that fracture later. But in the meantime, you can have some fun with what we made. We can make it be bigger in this direction. We can have it be bigger in that direction. We can have it be like that. We made a huge building now. And again, it's not going to take up much more memory than our original little building here. Now we're going to stick with our little building because even though it may not take up as much memory, it's still going to take up a proportional amount or more CPU power to actually calculate everything. So, there's still going to be some limits there. But still, pretty cool to be able to make your own procedural building like that. And you can refine this as well. Similarly, we can go to our reference box. These will all propagate down. So the depth of the room. Like so. Anything you want. All good. So I'm just going to keep it back to where it was, which was 2 by 2 by 6, and this is 4 by 4 by 8 for the actual sizes. Awesome. Oh, and I'm going to go into my camera, and I'm going to press space G. Oh, I'm actually going to my camera again. Click the lock, press space G, so our camera is like here. We can move our camera later, but now we might as well be able to get back to a nice kind of a bookmark of a spot. Awesome. On to fracturing.